Shapes of distributions. This is the second video, and we are starting with example 3, comparing data distributions. The double histogram shows the distributions of messages with emojis sent by a group of female students and a group of male students during 1 week. Compare the distributions using their shapes and approximate measures of center and variation. All right, so here's our double histogram. So at the top you can see this is for female students. At the bottom this is the histogram for male students. And along the vertical axis is the frequency, which we've seen in the past. So it goes from 0 to 14 and 0 to 16, but you can see the highest one here is 14 again. Along the bottom, it talks about number of messages with emojis. So we have 0 to 9 all the way up to 90 through 99. So you can see for the males, it doesn't go any higher than 79. For the females, it is spread out all the way from 0 to 99. All right, so the question again says, compare the distributions using their shape and approximate measures of center and variation. All right, so if we start by looking at the one for females, that's the one here on the top. You can see how it kind of goes up and back down. So this one is, in my opinion, close to being symmetric, which means, it's kind of a mirror image on the left side versus the right side. So for this one, your mean, your average would probably be the best representation for the distribution. Okay, and that's for your female students. So your mean is probably going to fall somewhere here in the middle in the 50 to 59 emojis category. All right, for the males, because the data is mostly on the left, that means it has a tail going down to the right. Okay, so most of your data here is where the bars are higher, but it is skewed down to the right. That's where the tail extends down in this direction. All right, so the data is a lot different for the males than it is for the females. So for this one, the 5-number summary, which means the median, would be the best representation for the data for the males, where the mean or the average was the best for one that's symmetric. When it's skewed, the 5-number summary really is the best. All right, so we already said that for females, the average probably falls around the 50 to 59. For the median, I'm guessing that it would be probably maybe in the 20 to 29. You'd have to, actually graph the data with your 5-number summary to see that. But in my opinion, just looking at the histograms, a typical female student is much more likely to use emojis than a typical male student based on the histogram provided. All right, and the data for the female students, because they are spread out more from 0 to 99, that means that the use of emojis tends to be different from one female to the next. So, here's on the lower end, these females are only using 0 to 9 emojis, and you've got some females using all the way up to 99 emojis. So that spread is definitely a lot wider, which tells you that from one female to the next, there's a big difference in how they use that. All right, here's a quick self-assessment. Compare the distributions using their shapes and approximate measures of center and variation. All right, so you're given 2 histograms here. You've got adults and teenagers, and this is the hours streaming videos per week. So this would be the number of hours they stream videos per week. And the same here for teenagers, and this would be the frequency. All right, so you can see the frequency here varies. The scale is different. The scale here is by 5s, and the scale here goes by 8s. So I want you to compare the distributions. Take a minute, just think about that, jot something down. and then come back and we will talk about it. All right, hopefully you paused the video and you took a few minutes to kind of see, kind of collect your thoughts about this and kind of jot something down. All right, so what we want to do is compare the distributions, just exactly what we've been practicing in the previous example. So if you look here, you can see that most of the data for adults is on the left, which means the tail comes down to the right. So this is going to be skewed to the right. For teenagers, you can see that this is kind of uniform, not uniform, but it's kind of symmetric about the center. So for the teenagers, the average or the mean would be the best indication for this data. For this one, where it is skewed to the right, this one, anytime you have data that is skewed, the 5-number summary is the best way to look at the distribution, which means your center would be the median. The best way to look at the center of the data would be the median for this histogram here. All right, writing. How does the shape of the distribution help you decide which measure of center and variation best describes the data? All right, so just like what we said, if it's skewed, you're probably going to use the 5-number summary. And if it's symmetric about the center, where it kind of looks equal on both sides here, then you would use the mean. Example 4, comparing data distributions. The table shows the results of a survey that asks men and women how many pairs of shoes they own. Make a double box and whisker plot that represent the data. Describe the shape of each distribution. Compare the number of pairs of shoes owned by men to the number of pairs of shoes owned by women. All right, so remember box and whisker plot, that's where we use the 5-number summary to make the box and whisker plot. So the first thing we need to do is say what numbers do we need to have on our number line. So if you come up here and look, you can see that we go from 2 up through 24. So for men and women, we're going to make 2 box and whisker plots, or a double box and whisker plots, means 1 for men and 1 for women. So we're going to need the numbers on our number line that go at least from 2 to 24. All right, so once we have our number line made, and I went ahead and made it from 0 to 24, that means all the numbers on here will be included. And what we need to do is look at the table, what they gave us. So the survey size. So this means that there were 35 men surveyed and there were 40 women surveyed. All right, they also give us our least value. This is the smallest value, and the greatest value. So remember, that's 2 of the components to the 5-number summary. They give us the first quartile and the third quartile and the median. So they actually give us all 5 of the numbers we need for the 5-number summary. They also give us a mean, which is nice to have the average. If your data is symmetric, the mean is the best indication of the data. But that is not needed for the box and whisker plot. So let's go ahead and see if we can do a box and whisker plot. Let's make the men in blue. All right, so first thing we're going to do is look at the least value here. So the least value is at 2. All right, so I'm just trying to put a dot there. And then for the men, the greatest value here is 17. So let's put a dot here. All right, so we have a dot at the lowest and the greatest. Now, the median is going to be the middle of our box. So at 7 for men, we're going to go to the median. It's going to be at 7. So here's 6, 7. I'm going to draw the middle line of my box. And then my Q1, first quartile, this is my Q1, is going to be at 5. And then my third quartile, my Q3, is at 10. So you can see they already give us the data we need to make this box and whisker plot. All right, I'm going to draw my box here in the middle and then attach my whiskers here to the box. All right, so that is for men. All right, let's change colors here. Let's go with pink for the females. So let's see what we have. We surveyed 40 women, but that doesn't go on our box and whisker plot. But the least value would be 5. So 4, 5. All right, and the greatest value is going to be 24. And remember, we're doing a double box and whisker plot, so that's why we're making a second one now for the women. All right, so now we have the first quartile, the median. I don't know why, but I like to put the middle in first. So 14 is going to be the middle. That's going to be the median. And then I have Q1, first quartile would be 12. And then third quartile, which is my Q3, would be 17. And then I'm going to create my box. And then just like before, not very straight line, but I'm going to connect my whiskers for my box, my double box plot. All right, so it says describe the shape of each distribution. So you can see that the distribution for men is kind of skewed to the right. And for women, the distribution is more symmetric. You can see that the whiskers are more about the same length. So this one would be more symmetric. This one would be more skewed to the right. All right, so what can we determine? If you look at the table again, or the box and whisker plot, it says compare the number of pairs of shoes owned by men and the number of pairs of shoes owned by women. So you can see that the women, the whole box for the women, which means your Q1 through Q3, is all above the data for the majority of the men. All right, so the centers and spreads of the two data are very different. So the mean, or the average for women, if you look at the mean up here, the average is almost double. And there's definitely more shoes for women, going from 4 up to 24. The highest number of shoes for men was 17. And again, this is just based on the people that were surveyed for this information. But yeah, you can see that based on the table and based on your box and whisker plots, it's easier to compare the data when you have a graph or a box and whisker plot, a histogram, any of those things to look at. So when you're comparing data, just know how to put the data to use by putting it in a histogram or a box and whisker plot and being able to look at the data in a useful way. That's all for this lesson. If you have any questions, please let me know.